Welcome everyone. This is Prompt Engineering for Developers, an introduction to prompt engineering and generative AI. So these will be our objectives for this meeting: to give a general introduction to what prompt engineering is, what are the best practices, and introduction to what exactly is generative AI, exploring generative AI tools for our use cases as programmers, and using Google Cloud APIs and Colab, also how to use generative AI with Python. So today's speaker, after I present, will be Jairobe McPherson. He's an AI ML customer engineer at Google Cloud, and he has Jamaican roots as well. So that should be interesting. Okay, so to start, what exactly is AI? So anything that is considered artificial intelligence in the context of technology is something that is able to imitate intelligent human behavior. So it can be any one of our senses or something that's characteristically human, such as walking, AI that controls robots. Physical movement is a human quality, so they're considered AI. Chatbots can mimic human speech and ability to generate text, so that's considered AI. Self-driving cars exhibit the ability to see and understand their surroundings. A subcategory of AI you will often hear about is machine learning. So machine learning applies to the AI applications that allow the system to automatically learn and improve from experience. So for example, an agent in a game that improves the more you play it. If any of you guys have ever heard of AlphaGo, that can learn Go, and certain gaming agents that can learn the more games they play. Those are examples of machine learning AI. Deep learning is actually another subcategory of machine learning. So deep learning actually uses complex algorithms that mimic the human brain itself. So if you've ever heard of neural networks, those are deep learning models because they're trying to mimic the structure of neurons in the brain, and it learns by mimicking that entire process of repetition, recall, and learning with progress. Okay, so here's another visual representation of that. Our our presentation will be focusing on generative AI, which is another subcategory. So under AI, you would have machine learning. Machine learning, you have deep learning, which is a type of machine learning, and then generative AI is a type of machine of deep learning. So to your right, you can see some examples of some generative AI tools that I'm not sure if you might be familiar with them. So for example, Midjourney. Anyone know Midjourney or DALL-E or have used them before? Can raise your hand. Midjourney and DALL-E are the most popular image generation tools. So generative AI, the name should be self-explanatory. It's used to generate original content. So using the techniques from machine learning and deep learning, it can create, based on data that it's trained with, it can create original content. So Midjourney, if you type in a dog flying, it can generate a dog flying. Originally, it can generate anything that can be said as a prompt. Most generative AI, they accept all input as prompt. So if you can type it out and it's comprehensive, the AI can generate it. ChatGPT and Bard, I think most people are most familiar with ChatGPT. These are language models. So they can generate text, they can understand text, they can mimic human speech and writing ability. 11 Labs is another popular one. This is for generating audio. So it mimics human speech. You can train it with recordings of your voice or someone's voice, and it can, with a prompt like say, hey, how are you? It will mimic my voice and say that those words in my voice if I train it with my voice. So this is actually a very controversial one because people tend to use these applications for scamming, but We don't encourage that. We're just appreciating the technicalities of this kind of technology and using it for safe purposes, obviously. HeyGen as well is one that can generate video of a person speaking. So if you give it a series of images and recordings of me, for example, as well as my voice, and then you prompt it to say, hey, put Darren in a conference room talking about Jim Squeecher or something, it will generate that. And you can have it say anything you want me to say on video. At the moment, most of these applications of the video technology aren't very convincing because you can see like the mouth movement is off and the facial muscles look weird. But HeyGen is possibly the most advanced example of this. All of these are generative AI technologies. Okay. So we just covered generative AI and we mentioned ChatGPT and Bard, which are the ones that can work with language. So that's our focus for today. We're going to look at LLMs or large language models. So these are the ones that can generate text content. And so here are some of the examples. I'm not sure if you guys are familiar with these ones that are on the screen, but for example, character.ai, you can create a character and then train it to have a personality, and then you can have a conversation with that character. So you can talk back to it and it will seem as if, oh, this is SpongeBob or whatever talking back to you. I think most of us are familiar with ChatGPT, and the model behind ChatGPT is actually GPT 3.5 or GPT-4. And Bard is another one. It's made by Google. The model behind that, the large language model behind the application is Palm 2. So ChatGPT is the app, the model is GPT. Bard is the app, the model is Palm 2. Llama by Meta, formerly known as Facebook, is an open source large language model. So this means you can actually go online on GitHub and you can get this model locally downloaded and you can modify it, you can run it, you can train it to do whatever you want. Claude is an alternative to ChatGPT and Bard. It's made by Anthropic and it can do essentially the same thing, maybe not as advanced as ChatGPT at the moment, but it's one of the strongest competitors. Bloom is another open source model that you can download, train. It's a collaboration of a lot of AI scientists just working together to build out this technology. So if you guys are interested in working on that further after this presentation, you should check these out. All right, so here is a short video that actually explains some more of the details of how these large language models actually work, like the science behind it.
Unless you've been living under a rock, you've probably heard that AI is getting very good at
Can you guys just confirm that you heard that?
Yes.
Okay.
Unless you've been living under a rock, you've probably heard that AI is getting very good at conversation. In fact, maybe you've even chatted with one of these AIs through a chatbot interface like Google Bard.
This is all thanks to a powerful kind of neural network called a large language model, or LLM. LLMs enable computers to understand and generate language better than ever before, unlocking a whole host of new applications.
In this video, we're going to talk about what LLMs are and how anyone can get started building with them, whether you're a developer or not.
Ready? Let's dive in.
LLMs are machine learning models that are really good at understanding and generating human language. They're based on transformers, a type of neural network architecture invented by Google. Now, what made the transformer architecture so powerful was its ability to scale effectively, allowing us to train these models on massive text datasets.
That's where the large and large language models comes from, both the size and complexity of the neural network itself, as well as the size of the dataset that it was trained on. For some of these models, we're talking about trillions of tokens from a bunch of publicly available sources. And it wasn't until researchers started to make these models really large and train them on these huge data sets that they started showing these impressive results, like understanding complex, nuanced language and generating language more eloquently than ever.
If you're already familiar with machine learning, you probably think about training a model for a specific task, like, is this tweet positive or negative, or translate this text from French to English. But what makes LLMs especially powerful is that one model can be used for a whole variety of tasks like chat, copywriting, translation, summarization, brainstorming, code generation, and a whole lot more.
Best of all, you can prototype language applications incredibly fast with LLMs, in just minutes rather than months. And you don't have to be a machine learning expert to do it. All you really need to know is how to write. So how do you actually use an LLM? Well, let's take a look. LLMs learn about patterns in language from the massive amounts of text data they're trained on. Then they take as input some text and produce some output text that's likely to follow.
Another way to say this is that LLMs are like really sophisticated autocomplete. So for example, if we give an LLM the input,
"It's raining cats and..."
it'll probably predict that dogs is the most likely word to follow. Now, this might not seem that exciting, but we can actually use this autocomplete-like functionality to solve tons of tasks just by writing strategic text input.
For example, let's take Google's Palm LLM and input this sentence.
I have 2 apples and I eat one. I'm left with...
The Palm model outputs the answer 1. In this way, we get the LLM to perform some simple math.
Or take another example.
Paris is to France as Tokyo is to...
The Palm model outputs Japan, which tells us that the model can not only complete analogies, but it also has some world knowledge that it's learned from its training data. Though I should add the caveat that not all of the knowledge that the LLM outputs is necessarily factually accurate.
Now, all of the text that we feed into an LLM as input is called a prompt. And it turns out there's this whole art known as prompt design, which is about figuring out how to write and format prompt text to get LLMs to do what you want.
For example, one way to structure a prompt is as an instruction, like,
write me a poem about Ada Lovelace in the style of Shakespeare.
Or explain quantum physics to me like I'm 5.
Or generate a list of items I need for a camping trip to Yosemite National Park.
This approach, using a single command to get an LLM to take on a behavior, is called zero-shot learning. But in addition to just providing an instruction, it can be helpful to show the model what you want by adding examples. This is called few-shot learning because we show the model a few examples. Like, here's a prompt for translating from English to French. First, we provide an instruction. Then we give some examples, establishing the text pattern. If we pass this prompt to an LLM like Palm, we get back something like the following.
The model did provide a French translation of lipstick, but you might notice that it went on to generate all these additional English-French translation pairs. This might seem a little unexpected, but the LLM is just completing the pattern that we gave it in the prompt. As another example, here's a few-shot prompt to convert Python code snippets to JavaScript. Our prompt starts with an instruction, then we have some examples, and finally the Python code we actually want converted. The very last part of this prompt is JavaScript : because we want to nudge the model to output some JavaScript code, just like this.
Note that in a real application, we probably want to parameterize the input instead of hard-coding it into the prompt. That way our users can provide the Python code that they want converted. And this is essentially how you would customize an LM for Python to JavaScript app.
Now you might be wondering what the absolute best way to write a model prompt is. And if so, we've got some bad news for you.
There's currently no optimal way to write model prompts, and that's because the results we get are so highly dependent on the underlying model. Sometimes small changes in wording or even word order can improve the LM's outputs in ways that are not always predictable.
That's why it's always worth trying out lots of different structures and examples and formats and seeing what works best for your use case.
There you have it. That's the magic of LLMs in a nutshell.
You can check out Bard at bard.google.com and definitely let us know in the comments below what you're building with LLMs.
Okay, so once again, for those that joined late, our presenter for today will be Jairobe McPherson. He's an AI and ML customer engineer at Google Cloud. And today he'll be showing you guys how to implement generative AI with Palm in Python and also share some prompt engineering techniques. So,
Yes,
welcome.
thank you for that introduction, Sean. If you all will bear with me for a minute or two, though, I need to figure out how I can get Zoom to run on my laptop so that I can control the slides. So give me about 2 minutes and I will hop on and we can get started. So apologies. Second.
All right, no problem.
All right, thank you for your patience, everyone. I think I'm in. So Sean, if you don't mind, if you can stop sharing, I believe I should be able to share my screen now and we can get started.
Yeah, sure.
All right, let me give this a go here. It'll share this tab. All right, is everyone seeing my screen? Yes? Cool, cool. Well, thank you all for having me. Good afternoon. As Sean said, my name is Jairobe McPherson. I am a AI customer engineer here at Google Cloud. I've been at Google for about 5 years. Most of that time has been spent working in our Google Cloud organization as an engineer. I did also spend some time working as a founder in residence, running a product and engineering team within Google Labs, working on 0 to 1 uh, stealth products in Google. But since then, I've transitioned back over to Google Cloud. A little bit about me. I was born and raised in Atlanta, Georgia. That's where I reside now. I went to Georgia State University. Um, my family actually is Jamaican, so I was not born on the island, but both of my parents were. So I try to go over to JA whenever I can. A couple of pictures here on the right, you'll see me hanging out with my family over there in JA. But glad to be speaking with you all today. As Sean said, today we'll talk about some of the techniques for leveraging these large language models. Hopefully, with some time at the end, we'll go through a quick demonstration. So hope you all are excited about the topics today, and I will go ahead and get into the material. As I do that, if there are any questions or topics that folks want to bring into the discussion, please feel free to bring them up. I much prefer interactive conversations as opposed to me just talking. So feel free to ask any questions. So, and Sean, we haven't gone through any of the what is prompt engineering or best practices or anything yet, correct? Or have you
No,
already?
that's right where we
Okay.
left off.
Okay, cool, cool. So the objective today is to talk a little bit about what prompt engineering is in that. We'll discuss, again, kind of just some of the foundational concepts of what large language models are. We'll talk a bit about some of the best practices, talk about some of the tools that you can use. Again, because I work at Google Cloud, a lot of the stuff that I will be communicating to you all is from the context of using Google Cloud as a platform for your LLM exploration. But many of the concepts and things that we'll talk about can be applied to other technology stacks as well beyond Google Cloud. So let's get into it. So this is me. So yeah, just a refresher for anybody that needs one in terms of what we're talking about when we talk about AI and machine learning and deep learning. A lot of people use the terms AI and ML interchangeably, but really there's kind of a hierarchy of these technologies, with artificial intelligence being the all-encompassing domain, having many subdomains under it, including machine learning, right? And so when we talk about artificial intelligence, we talk about synthetic or non-human machine intelligence that is being derived by some system. And machine learning is a method of essentially training machines to essentially exhibit that intelligence that we talk about with artificial intelligence, right? And then furthermore, as we talk about topics such as deep learning, which is what underpins most of the generative AI developments that are popular now, that is machine learning that is specific to using neural network architectures, that is architectures that are modeled after our own biological neural architecture in our brain, with multiple layers of neurons that interact in a programmatic sense to generate, essentially the machine learning outputs, right? So kind of an important concept to know, because as you interview at companies, they may ask you, well, hey, what's the difference between AI and ML? And kind of knowing how to expound on that is often just a sanity check on your understanding of the space. So just wanted to go over that as a refresher. When we talk about generative AI, we're talking about using deep learning methods that actually allow you to generate content as well as understand content, right? And so there are a number of companies and organizations that are now leveraging this technology to do very interesting things. And this conversation is all about helping you all understand how you can leverage that same technology to do interesting things. So a fun fact that I will bestow upon y'all that a lot of folks don't know is that this revolution that we're seeing when it comes to large language models and generative AI comes from Google, as does many of the industry standard technologies that are out there today. So I actually posed this question out to the group here. Does anyone know what the T in ChatGPT stands for? And if you do, you can come out and tell me or put it in the chat or something, but I'm curious if anyone knows what the actual T stands for.
Transformer.
Transformer. Okay, cool. Who said that?
Heron.
Who was it? Joe? Okay, so transformer. Does anyone know where the concept of a transformer model began in terms of what year and what led to the development of the transformer model? I'll give a second for anybody to chime in if they know. Ryan says 2016 Google paper. And actually, I was going to say you're half right. Maybe you're all the way right and I'm half wrong. I want to say that the paper was published in 2017. But to your point, Google published a paper called Attention is All You Need in either 2016 or 2017. I think it was 2017, that introduced the transformer model architecture to the world, right? And so that is the model architecture that underpins GPT, underpins our models, Palm, Lambda before Palm, and the next iteration of our LLMs, which is called Gemini, that should be released soon. All of these different models essentially stem from the research that was done at Google around how to build transformer models. So that's a fun fact for you. And so, yeah, LLMs are a subset of those capabilities where now we can use these models to not only understand and classify and make inferences and predictions, but we can actually use them to generate content as well as understanding content, right? And so one of the things that I think it's important for folks to understand when we talk about these models, specifically when we talk about the Google models, as well as OpenAI and Anthropic and otherwise, is you have models and you have products. So ChatGPT, that is a product. Bard, that is a product. There are a number of different models that these organizations have that underpin these products. So Bard right now is underpinned by a family of large language models called Palm. And ChatGPT, of course, is underpinned by the family of GPT models. But it's important to understand that there are different models with different sizes that are trained to do different things in terms of tasks, right? And so that is very important as we get into the subject of prompt engineering and utilizing these models, because you will find in using different flavors of the models, one prompt that works with model A or model version A may not work so well with model B or model version B, right? And so when we talk about prompt engineering, it's all about understanding for the specific model that you are leveraging, for the specific task that you are trying to receive or accomplish, in a set of requirements that you have established, what is the best way of prompting that model to get the desired output, right? If you don't have the understanding that there are different models and different products, it's kind of hard to do that. So we'll skip over this because you guys can watch that later. All right. So getting into prompt engineering. Prompt engineering, as we said, is all about crafting these input prompts, right? You want the model to do something, either generate some sort of text or understand some sort of text. You need to understand how to interact with that model, right? And so another term that's very important to understand is the term pre-trained. And so when we talk about these LLMs that are available off of the shelf, so your Palms and your GPTs, those are pre-trained models, meaning that the organization that is providing that model has already trained it on a large corpus of data and offered you that model for usage, right? In the sense where to pre-train a model is very expensive. It's very complex. It's not something that anybody can just wake up and do. But anybody can wake up and actually begin prompting the models, provided they have access to them. In a second, we'll talk about the idea of tuning some of these pre-trained models. But just understand that terminology, right? And so in many cases, what people don't understand, what users of this technology don't understand, is that many of these models are very powerful in terms of completing tasks out of the box when used with the right prompts. And so the act of prompt engineering is to find what those prompts are, to leverage the pre-trained models. And in some cases, if prompt engineering is not enough and doesn't yield the desired results, then you can talk about tuning a model and prompt engineering that tuned model, right? Very important, prompt engineering does not require any real programming or machine learning expertise, right? It's more so just understanding the structure. Now, with that said, while that lowers the barrier to entry in terms of people utilizing these models, for all of you on this call that are developers, I would challenge you and encourage you to try to understand some machine learning concepts, right? And understand programming, because then you'll have a better understanding of how the models work. So that even when you are doing your prompt engineering, you understand how the models are actually consuming those prompts and connecting them back to the output that you're getting, right? So very important technique. My hypothesis is that in the future, you will see much more roles and careers being built around this idea of prompt engineering, even more so in my hypothesis than traditional software engineering. So, a lot of people are saying that, prompt engineering, English is the hottest new programming language. There may be a future where folks are not actually in their IDEs coding in Python, but instead working in their prompt engineering IDE and figuring out how to write in natural language the thing that's going to get the AI to actually do the hard work. So that's kind of the overview of prompt engineering. Let me pause here for a second and just take any questions that anyone has thus far. Does anyone have any questions or thoughts or comments? Anyone going once, twice?
Okay.
I heard someone talking. Does someone have a question?
Yes, can you hear me?
I can hear you, but now, yes.
Okay. So, with regards to providing prompts for the AI, do you guys have like a template?
That's a good question. We're going to talk about that. Yeah, I'll leave it at that. Actually, no, let's talk about that now, right? So part of prompt engineering, it really is just figuring out in natural language how to get the right response. And so what we're going to talk about somewhat today is how you can actually essentially create your own templates that will help you with prompt engineering, right? So let me actually go to the next slide. Uh, LangChain, by the way, for folks that have not used LangChain, just as a sidebar, it is a framework and tool for actually chaining together prompts and interacting with models kind of in a sequential manner, right? Where you can kind of have the model complete different tasks in sequence by providing them prompts. And so we might be using some of that. But right, before I talk about the prompt tuning, templates. So many of these models really, really need to understand who they are in the context of the tasks they're being asked to perform, as well as understanding the context of the tasks that they're being asked to perform and the constraints. And so when you talk about prompt engineering and potential templates, you have to kind of think about how these models actually process information. And in many cases, what you'll find is that when you present the models a template that is tracking with kind of what I just described there, here is the context about who you are. Here is the context about what you're being asked to do. Here's the context about your constraints and the tasks that I do not want you to perform. And then also, and we'll talk about the different methods of providing examples. Here are some examples of a input and output that I expect from you. That is kind of the high level template, like the most basic way you can think of templating a model or prompt for a model that you will want to implement when you're interacting with these models. And so I typically recommend that anyone who is interacting with these models and really wants to maximize the quality of the response, they at minimum, even if it's not even a formal structured way, provide those things in a pseudo template to the model, and you will get vastly better results than if you were just to ask it a question, right? So again, just as a review, you tell the model who it is in the context of the task. You tell the model any additional context on the task, and we'll provide examples of this that you needed to have. You tell it what not to do, and then you also can give it examples if examples help, right? And when we talk about examples, there's this concept of zero shot example prompting, few shot, one shot and few shot. So 0, 1, and few. So basically those, kind of are akin to just asking a question with zero shot, where you're not providing any examples at all to the model, and you just ask it a question. That's zero shot. One shot is providing one single example to the model and saying, here is what an input output pair looks like. Use this to generate your output from my prompt. And then few shot. Few shot is where you are providing a handful, typically anywhere from 3 to 10, could be more, examples of the behavior you're expecting from the model, right? And so on most tasks, even providing one single example with one shot typically performs better than zero shot. So that was a long-winded way of saying, yes, there are templates that you can provide to the models, but there are no rigid and really strict templates that you have to provide to the models. You can kind of make up your own, and that flexibility is kind of the one of the really cool things about leveraging generative AI, right? Like there's no syntax that you necessarily have to follow for most models. So hopefully that answers your question. All right, where are we at on time? going to try and wrap up some of these. So prompt tuning. It's very important that you all understand that there's a difference between prompt engineering and prompt tuning. And there's also a difference between prompt tuning and model tuning. So there's a lot to unpack there, but let's start with the difference between prompt tuning and prompt engineering. So we've covered prompt engineering, where you are machining the inputs to the model to figure out what input yields you the best model behavior. Now, when you talk about prompt tuning, this is actually a method of you actually tuning the model with prompts, right? And so this is a process where there may be a section of the model's parameters that are actually adjusted based on the prompts that you've fed in, right? And so the key takeaway in terms of distinguishing between prompt engineering and tuning is that with prompt engineering, you are not modifying the model itself. You're just modifying how you interact with it. With prompt tuning, you are modifying some of the model, not the whole thing, right? So when you need to actually customize a model because you've realized prompt engineering isn't really yielding you the best results, that's when you can look into prompt tuning, which is kind of a lighter way of doing tuning of a model, wherein on the other end of the spectrum, you have full tuning, where you are literally providing your own data sets and retraining the model, that is readjusting all of the parameters and the weights associated with the model with your own data, right? That's full tuning. And prompt tuning is a way of essentially just adjusting a slice of those, right? And there's kind of different methods that you can go for prompt tuning, but it is different from prompt engineering. So let me pause there and just make sure that that resonated with everyone, and ask if anyone has any questions about the difference between prompt tuning and prompt engineering. Did it make sense to everybody, or are there questions about that process?
Yeah, I have a question. Let's say you are developing a tool that provide like say it have PowerPoints and PDFs, right? And you present it to that to the large language model, right? Which category would it fit into? Prompt tuning or prompt engineering? Like you want to extract information. So let's say you're using it for other people to extract information, like they can ask information about that PDF or PowerPoint.
Okay, so let me play this back and make sure I'm understanding, right? So you have your PDF or your PowerPoints, and you want to essentially feed it into the model and have people ask questions about extract information. So I would categorize, if I'm understanding correctly, the task is to extract information from your PDF and your PowerPoint. And your question is, in that extraction task, would it be better to work with a like a prompt tune model or just do prompt engineering? Is that kind of the question?
Yeah.
Yeah. So yeah, that engineering. I would try prompt engineering first. And really, I would say this is probably a rule that holds true regardless of the task, right? So when you talk about how you should leverage these models, your first step should usually be prompt engineering. You should at least spend some amount of time seeing if you can play around with the prompts and get the model to provide you the correct output based on your task, right? Where in your example, if you're extracting information from this PDF or these PowerPoints, try prompt engineering and see if you can get it to a point where it extracts the information in a in a manner that is, meets your quality standards. The moment that it does not, and you've tried a couple of prompts, you've gone through some prompt engineering iterations, and it doesn't, then you can move on to exploring either prompt tuning the model or fine tuning the model or full tuning the model, right? So yeah, that's kind of like the flow that I would recommend. Prompt engineering first, some intermediary tuning if prompt engineering isn't working, and then full tuning if nothing else is working, right? Because when you think about the spectrum of complexity for implementing all of those, full tuning a model is a pretty sophisticated process, right? And I can tell you that firsthand because I've done that with some of our large language models here within Google, and yeah, it's pretty sophisticated, and it takes a lot of compute to actually do, right? So you want to avoid full tuning or even fine tuning if at all possible. Start with prompt engineering. Um, Hope that answers the question. So cool. So just in terms of how you interact with some of these models, if you are using them via APIs or if you actually are interested in trying to tune or fine tuning these models yourself, if you are going to interact with the models, even using LangChain or other frameworks, you'll want to understand the concept of notebooks versus IDEs. A IDE, hopefully most of you as developers are already familiar. That's your integrated development environment, where you'll go in and begin writing your code, likely in Python if you're working with LLMs, versus a notebook is more of a collaborative way of writing and experimenting with code, right? So, notebooks provide a way to not only write and execute code, but also document that code and share it in a manner where you can build things in an experimental way that you can share and collaborate with others on, as opposed to developing things in your IDE and then having to export your code or check it into a repository and share that repository and download it, blah blah blah. So get familiar with Jupyter Notebooks if you're not familiar with them yet, because it's a really good way to actually mess around with some of these things and experiment with other collaborators. Uh, but if you actually want to build systems, fully end-to-end systems that will be leveraging AI and ML and LLMs, you will want to actually, build those things in an IDE. One thing that's not necessarily mentioned, I think, in the presentation, but I think is very important for any developer that wants to begin working with these technologies is containerization. And so for those of you who are unfamiliar, there is a way where you can write code, where you can package it up and easily run that code in essentially almost any environment, right? And so, that methodology, the associated technology to that is containers. And so Docker, if folks have heard of it, is probably the most widely used and well-known container development and management platform. And so I encourage everyone to get familiar with Docker. If you are writing code in your IDEs, whether you're talking about doing LLM work or otherwise, learn how to Dockerize and containerize your code, because what you can do is essentially take your containerized code and hand it off to someone else or a different environment and have them very easily run that code, right? And so the alternative to using something like a Docker is, yes, Kubernetes is actually a container orchestration platform, right? And so kind of the flow would go if you were trying to build a fully end-to-end productionized, piece of software or platform. You would write your code and you would package your code using Docker. And Docker has this concept of creating an image. An image is basically a runnable packaging of your code. And with that container image, you can now deploy that into an environment and have that code run anywhere. And the way that you would actually manage some of that environment in terms of where your code runs, how people access it, when to start and stop your code is using Kubernetes which is a container orchestration platform, right? So very important for ML specifically. There are a lot of very, very interesting tools that you can use from Google Cloud, as well as the other public cloud providers like AWS and Azure that have a dependency on the code being containerized to run, right? So definitely get familiar with that if you're not. In terms of languages, mostly if you're using Notebook, if you're doing ML work, you're going to be using Python. R is another library that you may come across. It's, traditionally used more for like statistical analysis, numerical, quantitative analysis, but as you can imagine, there's a heavy overlap with ML in that space. So R is another one. Cool. So we don't need to watch this video. I'm going to show you one is Colab is Google's hosted notebook environment. So it's pretty cool. Essentially, anyone can use it that has a Google account. It's just essentially like collab.google.com. So in Colab, you can jump in, you can begin creating Jupyter notebooks that you can then share with other people for collaboration. You also can, if you find notebooks that other people have published on GitHub and otherwise, you can import them into Colab and you can begin running them. So, again, if you're unfamiliar, check it out. It's a really cool way of developing and sharing out things that you're working on. I personally have switched from prototyping a lot of things and uploading them into repositories like GitHub and essentially doing most of my development now in terms of prototype and experimentation in Google Colab, right? So definitely check that out if you are unfamiliar with it. All right, cool. So I've covered all of that. The next thing I want to talk about before I get into the demo is a more advanced method of interacting with large language models called retrieval augmented generation. And so we'll talk about what that is, but before we go into that segment, again, want to pause and take any questions, comments, or feedback on the content thus far. How's everybody doing? Is everyone awake still, hopefully? Kadia, you said, can you refer where we can learn from a beginner? Let me see if I can see the rest of this question. And sorry, I haven't been looking at the chat much. Okay. Can you refer where we can learn from a beginner level or completely blank level, e.g. websites? So Kadia, are you asking more so on an ML front where you're interested in just starting from a foundational place for working with ML? Or are you talking about, I guess, even before we get to ML? Or are you specifically talking about ML? Kadia, you there? Okay, I'm not hearing Kadia. Maybe she left. So in terms of where you can learn from a beginner level, I will post in here. I'm gonna assume, oh, no worries. That's fine. I'm gonna post something in here. In terms of starting from a foundational level for machine learning, I'd recommend everybody check out the machine learning crash course that Google offers. So this is a free course. Anybody can access it. You go to this website and it will kind of take you through the beginner introduction to machine learning and building machine learning systems, right? So if you're looking to start from ground zero with ML, try that course. It will give examples on what ML is. I think more importantly than the actual hard skills of building, training, evaluating, and deploying machine learning models, what that class will focus on, or that course will focus on, that's really important, is machine learning problem framing, which means understanding, given a problem, whether or not using machine learning is the right solution, right? Because, the technology is popular, it's really cool, but you don't always have to use machine learning. And in many cases, machine learning is not the answer for what you're trying to do. So I encourage everyone to, whether it is this course or another course, take some time to think through the actual strategic process of understanding when you should actually be using machine learning versus using another technique, right? Um, because it's not something that you want to throw at everything, right? In terms of starting, from an even more basic level, learning Python, learning how to code websites, that sort of thing. There are a lot of different tutorial, platforms and sites out there. I really like W3 Schools. So a long time ago, over 10 years ago when I first started programming, W3 Schools is actually where I learned how to do my first real programming. And using that resource alone, I was able to build a lot of really interesting applications just using W3 Schools. But there's a lot of them out there. Tutorials Point, Coursera is great if you all have access to it. Plenty of resources. But for ML, I would recommend the Google course. All right. So I think we have 15 minutes left. Let me jump through just what RAG is, and then I want to go into a quick demo, and then we can wrap up here. Stack Overflow is my teacher. Yes, to Joel's point, Stack Overflow is your Bible when it comes to development. And if it is not your Bible, it will be your adopted Bible after you get into programming for a little bit of time, right? So definitely leverage Stack Overflow as a resource when you run into tricky things with programming. All right, so retrieval augmented generation, RAG. Let's talk about it. This is one of the hottest new techniques for actually leveraging LLMs. And so before we talk about what it is, let's talk about what using an LLM looks like without RAG. So everyone knows that they're really good LLMs for generating content, understanding content. We talked about how they're pre-trained on a bunch of data, right? So again, when we talk about the pre-training, these companies like Google, OpenAI go to the open web and basically suck up a bunch of data and train models based on the data, right? So they're all trained on publicly available corpuses of information. And many of tasks can be leveraged with these models, from text generation, summarization, information extraction, like the example we had, Q&A, lots of things you can do with them. So what's the problem? The problem is the way that these models work, sometimes they're not the most trustworthy, right? And that's a function of the data that they were trained on. That's a function of how they were trained, and gaps in their understanding of information. But if anyone is, not familiar with the idea of hallucinations, basically it is a phenomenon where the LLMs just make up stuff, right? And that is probably one of the biggest obstacles to actually leveraging these LLMs in a useful manner, right? It's the fact that they have a tendency to make stuff up, right? So when we talk about RAG is a way to minimize some of the hallucinations that these models inherently have, right? And so if you can see my screen here, a great example of this is asking a pre-trained model, what is LangChain? So we talked about LangChain being a framework and tool that you can use to chain together prompts and interact with models, that sort of thing. LangChain actually has nothing to do with blockchain, which is interesting because when I first heard about LangChain, I automatically thought that it was some new chain that I needed to learn because there's a new one every week, apparently. But it isn't, right? And so if you ask some of the LLMs, what is LangChain? Because they were actually trained on information that predates LangChain even being invented, it doesn't know what it is. But instead of telling you it doesn't know what it is, it makes it up and tells you, oh, this is something that's blockchain based and blah, blah, blah. It's wrong, right? And so RAG is all about minimizing the tendency for the models to do that. So how do you do that? And also, how do you get the models to respond accurately when the data that you're asking it about does not reside or did not reside in the corpus of data that the model was trained on? Your own private data, in other words. How do you get it to respond based on data that you provided it and nothing else, right? Well, you need to go and essentially put this data into the model so that it has some sort of understanding of it and uses that understanding of the context in order to respond to your prompts, right? And so that is what RAG seeks to do. Now, outside of RAG, there we talked about how you can try and do fine tuning. We talked about how you can do prompt engineering. We didn't talk about, but another option is to actually have a human in the middle, human in the loop, and have them look at the responses from the LLMs to make sure that they're correct. But none of these things are really, really great solutions for minimizing hallucinations, right? Fine tuning and full fine tuning, expensive, sophisticated, difficult to do. You have to know what you're doing. And at the end of the day, it still might not even work. Making humans come into the picture, that kind of nullifies the whole point of using the LLM and AI in the first place. And then prompt engineering, we talked about, this is where you should start. But in many cases, you may just not get the performance that you want, based on the model fundamentally not having the right context. So enter RAG. RAG is a way for you to essentially append a information retrieval process before you actually query the model, right? And so what happens when you're using RAG is you take an input prompt into a model and you basically connect it to a system that will do a search against a corpus of data that you've provided. And it will retrieve the relevant data to the prompt that's coming in and essentially add that into the prompt before it actually queries the LLM, right? And so this is actually a way of going back to the question that we had earlier, leveraging almost in a way prompt engineering, where you have a template that's been developed, again, understanding or helping the model understand who they are, helping them understand the context of the question and the prompt, and the context of what you're not looking for and examples. So when we talk about RAG, RAG is all about using an automated retrieval mechanism to provide that context into this high level prompt engineering template, where in this example, the context is the retrieved information that you would get from this retriever system that sits in front of your LLM interaction, right? And then now having the context and relevant information to the question that's being asked, the model is going to be much better suited to actually respond to the question itself, right? So I'll speed through this because I want to show you very quickly a demo. Vector search is actually a key component of this. Vector search is a method wherein you take content or data and you transform it into a vector. These vectors are called embeddings. Embeddings are actually how machines understand information that you feed into it. So, whether you're talking about an image, whether you're talking about a block of text, whatever it is, models in terms of machine learning and deep learning under the hood are just a bunch of math and probability distributions. And so when you feed in a block of text or an image, models don't understand that. What they understand is ones and zeros. And so there's a way by which you can, or ways by which you can create embeddings of information so that you can put them into a store that, basically using some sophisticated math can understand the relevance between two separate entities. And so the example that I like to give is that if you had an embedding representation of the word man and the word woman, and you put them into and you created embeddings from them and put them into a vector database, and you also had the words king and queen, and you created embeddings and put them into that same vector database, the database would understand from a quantitative perspective that the numerical representation of man and woman is similar to the numerical relationship between king and queen, right? So it would understand that. And based on that, you can build search systems that can then be used in a RAG workflow or otherwise, right? So if all this sounds kind of crazy and complicated, it's because it is. So don't worry if you don't get all of it. Right now, I'll share some of this with you and you can do your own research. But basically how you implement RAG is you build a vector search store and you query that vector search store and provide the results from that query into your prompt before you make the actual query to the LLM. I am going to show you how to do that really quickly before we end. We are going to use GCP. We're going to be using an API that is called the Vertex AI Text Embedding API and Vector Search, where we essentially will take some data and we will convert it into embeddings. We will store that in the vector search store, and then we will use that search store to make a query to the PaLM to LLM in order to get our results. So I'm going to try and do that really quickly here and let you all get out on time. Let me share this screen here. 1 second. All right, we're going to share this tab.
As it relates to RAG, I think it more answer the question that I was asking earlier on.
Okay. Good. Yeah, I mean, you again, even with RAG, I would start by building a system like that. I would try and just prompt engineer it first. If it didn't work, then I would look into something like tuning. Then I would look at RAG, and then I would look at full tuning. And if all of that doesn't work, then you can combine RAG plus a fully tuned model, right? So, but anywho, moving on to the demo, I will share this out with Sean and Darren, so you all have access to it because you can run this on your own. But this is a lab that the Google Cloud team has put together for document Q&A using RAG. I'm running it in my Jupyter lab environment hosted on GCP. And so basically what this notebook is all about is using RAG to essentially ask questions about our Google Cloud generative AI documentation, right? And so we're going to install some of, and actually, we probably don't have time to run through all of this, but we'll try and run through what we can. Got to restart the kernel. All right. So you install your dependencies up here. You have to authenticate your environment. If you're running this in Colab, you'll do that. There's some more libraries that you'll need to use. You'll see here that we're using Vertex AI, language, text embeddings, and the text generation model to actually query the model. And then you also need a GCP project as well. So that may be something that you all will need to find some funding to do because you need to have a credit card in there if you want to actually do anything that costs money. So you plug in your GCP project, assuming that you have one. You select the region that you want to run all of this code in, essentially. And then this code actually goes to our a GitHub location that has a bunch of URLs that point to our Google Cloud documentation, right? And so this code actually goes and essentially pulls in all the documentation from each one of those links, right? Here's a function here where it is going to essentially pull out chunks from each one of those documents. I'm going through this quickly just in the sake of time. And so as it pulls out those chunks, then it is essentially going to store them into a data frame. You can kind of compare the relative length of the chunks that come from the documents. And this may take a little bit to finish, so I'm probably going to have to just read through some of this. But What you do when you have the chunks of data from the documentation is you will then define this text embedding model that is going to take the chunks and convert them into those numerical representations, the embeddings of the chunks, right? And those will then get stored into your essentially your vector store, right? So this is the code here that creates the vector store. This is the code that actually defines how you are going to chunk up the text that you're getting back from the documents. And then this code, when it runs, if we were running it, it would actually show you kind of what the what's in the vector store. And so again, don't have time to run it now because we got to wrap up in 2 minutes. But when you go through this notebook, you'll see if you just use the model off the shelf and actually ask how long will the stable model version of Text Bison be available, it doesn't know because it doesn't have that context. And as you go through the lab and actually use your vector representation of the documents that have been provided on all of our release cycles, you will find that after you go through this and re-ask it the question, here's the prompt that you would ask it with the context that you're pulling from the vector store. You get to a point where it then miraculously has knowledge given the question that you're asking it, right? So we unfortunately ran out of time. I was probably a little bit too long-winded, but this is a very easy code lab to go through. It's pretty well documented. We'll send you the link. Go through it. It's pretty cool. And you can kind of follow the same model if you want to try it on other documents in terms of implementing RAG. So I'm going to stop sharing now. This has been hopefully helpful to you all. Let me put my email here in the chat for everyone. You all can find me too at justjrobe@google.com. I'm happy to speak with anyone who has an interest in learning more about some of these technologies. So John, Darren, I'll kick it back over to you both to kind of close this out. But again, thank you all for attending today, and hopefully you learned a few things.
All right, thank you so much. So wait, does anybody have any questions?
Cool. I actually need to run to another meeting, so I apologize for leaving really abruptly. But again, I'm here for other questions. Feel free to email me, and I will provide some additional materials for you all to learn, via Sean and Darren. So thank you all for your time today, and I hope you enjoyed the presentation.
All right, thank you for coming, Jairobe. Really appreciate it.
All right, take care, everyone. Bye.
Thanks again.
All right, guys. So thank you all for coming to this meeting. I hope you guys learned something today. And if you guys don't have any more questions or anything, then I guess this will be the end of the meeting and also the club's last meeting for this semester. So well, thank you guys for coming, and wish you all the best in your exams.
You as well. Thank you so much.